we are only looking at the magnitude, which is V on U. But magnification can be, you can see plus or minus V on U. When it's like this, we are not only looking at the magnitude, but the plus and minus means something. Okay, what does it mean? If an image is virtual, it is formed behind the mirror. So object is here, and then image is also here. Image is also behind the mirror. Over here, you realize that if we are looking at object height and then image height, it is along the positive, both are along the positive y-axis. Both are along the positive y-axis. Magnification is equal to V over U, which is also equal to H naught, Hi on H naught. So I can equate M to Hi on Ho, because this is equal to the same thing. So when you see, when image is virtual, when an image is virtual, then the sign attached to the magnification, if there is a need to look at the sign and not only the magnitude, then you see plus V on U, plus V on U. And the plus indicates that the image is virtual, meaning both objects and then image are at the same orientation. Both objects and image are at the same orientation. So usually we attach signs to the magnification. Okay, if there is a sign, the sign there is to tell you that the image is either virtual or image is real. If there is no sign, then we are interested in just the magnitude. Then we put it in this bold line to indicate just simply V over U. So open your eyes to when you are given such situation. Then if the image is real, a real image is formed at the same side as the object. So in this case, we expect it to be somewhere here, if the image is real. Now look at the object. M is equal to V over U, which is also equal to Hi on Ho. Look at the image orientation. His along the negative y-axis, okay, and then Ho, objects, is along the object positive y orientation. So we have M, which is equal to either minus Hi on Ho, and it's also equal to V on U. And when you sort of divide through or multiply through, we have M giving us Hi on Ho, which is equal to minus V on U. Since this ratio is M, we conclude that M is equal to minus V on U. So if you see a minus sign, then it means the image is a real image. A positive means a virtual image. So as I said, sometimes when you read, there will be sign conventions to them. This is what it simply means. Are we okay?
Sir, please, could you come again?
Okay.
I'm
For
not
the
getting you.
for the last time, pay attention. Magnification, whether the image is enlarged or reduced, okay, is what we mean by magnification. Sometimes when we are only interested in the extent of magnification, how the image seems to be magnified or diminished, if we are only interested in that number, it is magnified twice. It is reduced to half of the size of the objects. Then over here, our interest is just on the extent of our magnification. So in that case, the linear magnification is indicated as just V over U. So when we indicate this, then we are only interested in the value or the magnitude of linear magnification number. Maybe image is magnified twice. Image is magnified 3 times. Image is reduced to half of the object size. Okay, so here we are interested in yes, linear magnification equal to 2. Linear magnification equal to half, and so on and so forth. Are you okay?
Yes, please.
So here the interest is just on the number, or yes, the extent of magnification. Sometimes we attach signs, either positive or negative, to the magnification. And if you see a sign, then we wouldn't indicate linear magnification M in this line, because the line simply means that we are interested in the magnitude. So if you see M, linear magnification is equal to plus V on U, or this is equal to plus 2. What does it mean? If you see M is equal to minus V on U, and this is maybe minus half, what does it mean? This is what I'm talking about. Are you okay? Here, I cannot put linear magnification in this line, because the moment I bring this absolute value or magnitude sign, it means I'm not interested in the signs. Then this and this must go off. Please, class, are you okay? Hello, are you okay?
Yes, please.
But if I am interested, then I just write this as M is equal to maybe plus 2, or M is equal to minus 2. So if there is a minus, if there is a plus, what does it mean? And that's the explanation I'm giving you. If the image is a virtual image, it will be formed at the back of the mirror. Whether diminished or magnified, virtual image will be formed at the. So this is object height, and we have image height here. So in that case, magnification, which is equal to V on U, also equal to HI on HO. Object height is positive. Image height also positive. So in situation like this, because M, okay, is equal to plus HI over H naught, and this is also equal to V on U. This is M. We conclude that, oh, okay, then M is equal to positive V over U. So this M caters for this, and then we equate M to this. And this indicates that the image form is virtual. This is a virtual image. So if M is equal to plus 2, then it means image is 2 times magnified, but a virtual one. Image is 2 times magnified, and the image is virtual. Class, are you fine?
Yes.
Ekweadoma, if image is real, if image, hey, Inshira and Co, the 3 Inshira, Resi, Inshira Ba, Inshira, are you all here?
You know that people have the concept that it was difficult. But
Hey,
I made up my mind.
iPhone, iPhone, I'm getting feedback of you. Now, if image is virtual, hey, real, if image is real, real images are formed at the same side as the objects. So HI. Real images are always inverted. Now, magnification M is equal to HI. This time HI is along the negative y-axis. So we measure up image height this way. So certainly it's below the horizontal. And then H of the objects along the vertical. This is equal to V over U. However, when we multiply through by negative or divide through, we have M equal to HI on H naught, which is equal to negative V over U. This in itself, this ratio in itself is equal to this. So we conclude that M is equal to minus V on U. So if image is real, it can be indicated as minus half, meaning that the image is a real image, but it is diminished. The size of the object is reduced to half, or the size of the image is half of the size of the object. That is what it means. So in determining this signs, we use object height, image height, and then object height to deduce this signs attached to the magnification. But if we are only interested in the number, then absolute magnification, linear magnification is equal to 2. Then we go our way. That's what I mean. Any question?
Studio.
Hello, Akria.
It doesn't mean all virtual images are magnified.
Oh, it depends on the kind of mirror. As for the values, I just guess something, okay? But it depends on the, don't forget, convex, concave mirror magnifies forms a virtual image on only one situation. And in that situation, it is magnified. Then convex mirror forms virtual images no matter the position. So the
We have about
numbers.
a plain mirror.
Oh, plain mirror. When you look at yourself in the mirror, your head is always the same.
So yeah, but you're saying all virtual images are magnified.
Oh, if we don't forget that we are talking about spherical mirrors. Okay. Okay.
Yes, sir.
So this does not apply to plain mirror. For plain mirror, a magnification is always equal to 1. Amma, quickly, let's move
Sir,
on. Mhm.
sir, please, about the linear magnification and the magnification itself. How will you know which one? How will I say first? How will the question be set like for you to know you're supposed to use the absolute value or
Oh,
just the normal
it
magnification?
will be stated. It will be stated. Please, we don't have difference between linear magnification and absolute. Absolute just means we are not interested in the signs. Okay. The absolute simply means we are not interested in the sign attached to them. But it's the same as linear magnification. They are not different. Okay.
Okay.
So we'll solve a question. So, and even the example I gave you applies that. So you, as we move forward, you understand. In using the mirror formula, in fact, there are some key conventions which goes with them. There are some important conventions which must go with the mirror formula. So we have what we call the RP convention. We have, please, can you see clearly from the board?
So,
I want to reposition it a little bit. Let me on the lights. See if that will save us. So we have RP, real expositive convention, RP. The RP convention, meaning real expositive. Under this convention, everything real is considered to be positive. So under this convention, everything real is considered to be positive. Anything real is considered positive. So if real real objects, image, principal focus, radius of curvature, if all these are real, if they are all real, if are real, then it is treated as, then it's treated as positive. If they are virtual, they must be treated as negative. Okay. On the other hand, if the above, I'm referring to this, are negative or are virtual, treat them as negative. Under this convention, anything real is considered positive. Anything virtual is considered negative. So if you take concave mirror, a concave mirror, Charlotte, are you there?
Yes, please.
If you take concave mirror, look at it. This is a concave mirror. Put it at the back. A concave mirror has a real principal focus. What is the principal focus? And the principal focus is the focus. The principal focus of a concave mirror, okay, is a point. It's a point on the principal axis where paraxial rays. What is paraxial rays? Paraxial rays are rays that are parallel and close to the principal axis. So it's a point on the principal axis where paraxial rays converge after reflection from the mirror. So for concave mirror, it has a real principal focus. Its principal focus is real. Because its principal focus is real, it means that then the focal length, it means that the focal length would also be, is real. So F for concave mirror is positive. F for concave mirror is positive. Why? Because this point where paraxial rays converge is actually real. It's a real thing. Class, are you okay?
Yes, please.
Now,
Yes,
object.
please.
Object is always real. Object is always real. So under this convention, object distance U, object's distance U is positive. The center of curvature is also real, and so the radius of curvature is also positive for concave mirror. Now, image depends. The image depends on whether is the image real or the image is virtual. If the image is a real image, if the image formed is real, then treat V is equal to positive. If image is real. If the image is not real and is virtual, then V must be negative. If image is virtual. So it's like we are attaching these signs to them Okay, when the image is real and all other variables real or virtual. So for concave mirror, F is real, R is real, U is real. But V, the V depends whether the image formed is real or is virtual. That's the whole thing. Any question? Before we look at convex mirror, what pertains for convex mirror? Priscilla, do you have any question? Or everything is
No,
crystally clear and crystally clear.
yes, please.
Okay, then let's look at for convex mirror. Convex mirror curved within the reflecting surface curves outwardly. Objects, a real image is always placed in front of the mirror. So the object distance is always real. But this one has a virtual principal focus. And AMA, the principal focus of a convex mirror is a point on the principal axis where rays that are parallel and close to the principal axis after reflection appear to be diverted from. Is that point on the principal axis where reflected rays that are close and parallel to the principal axis, okay, after reflection appears to be reflected or diverted from. And this point, which is F, is not real. It appears. So for convex mirror, F is, so U is positive, but F is negative because it appears. What will you make of R? Would R be positive or negative? Amma,
Sir, please, about the definition for the principal focus. He said the reflected rays
of
appear,
a convex mirror.
yes, the reflected rays appears to divert from
to be
principal focus.
to be diverted from.
Okay. But
This
sir, they are all converging.
they are one converging. This mirror diverges rays, parallel rays. Convex mirror diverges. Okay.
Yes, please.
So the diverted or the reflected ray appears to be diverted from this point behind the mirror. So
Okay, I've seen it.
as I ask the question, what will you make of the radius of curvature of convex mirror? Will it be positive or negative? Ekweadoma, the radius of curvature of convex mirror, will it be positive or negative?
Negative.
It's negative. Chrysler, what will you make of the image distance for convex mirror? The image distance V of convex mirror. Do you think this will be positive or negative?
Sir, please, I think it will be positive
What's your reason, Chrysler?
because like it's formed at this side, like
Come again.
it's
Your reason is very, very important. Why do you think it will be positive? Okay, let somebody else
wait.
contribute. Mhm.
They'll be formed that this has a negative rather. Negative.
Why? Still, why?
Because it will be formed at the side. Like it actually isn't there. It appears to be there. Like, I don't know what I could say.
Okay, you have shared your view with us. I want somebody else to also judge what you think view would be for convex. Charlotte, what do you think for convex mirror? Would V be positive or negative? Lizzie and Co, you are also here. Okay, Racy.
Mr. Dia,
Mhm.
please, V will be negative.
Why?
Sir, because I think that's like this one. U is positive, so like V has to be negative, so like they can cancel 10.
I won't mind. Racy, your reason doesn't convince me so much. Please, if your hand is raised, go ahead and contribute.
Sir, please.
Go. Mhm.
Sir, please, what's the question?
Hey, you don't have you don't have the question and you want to answer.
Sir, no, that's a rate, man.
My question is that we want to judge how the sign to V for convex mirror. Would V be positive or negative? And each choice you make, the Y is very important. For the image formed by convex mirror, would V be positive or negative? Yes. Alvina, in fact, you have to say something. Oh, Effie, you are all here. Sawa, Yabali, Zilin. Hey, area say, people who yet they don't. Who wants to talk? I have seen two hands raised. Please, if you have raised up your hand, you can go ahead, though, because I need to stroll before I get to the names.
Okay. Mr. Here.
Ishra.
Please, I think that it will be negative because it will be negative because the image form will be virtual.
Okay.
So,
Nanepia, your hand is up.
image form-
Okay. Ishra, thank you. I would answer. You shall see if you are correct. Nanepia, your hand is up too. Nanepia. Okay. Yes. You see, convex mirror always forms a virtual image. Convex mirror always forms a virtual image and diminished. So for the sign, then we expect V to always be negative because the image form is always virtual. So for concave, it can be plus or minus because concave has the ability to form either a real image or virtual image. But as for convex, V must always be negative. Take notes.
So have you seen? I said the V will be negative.
Yes, you said it, but your explanation was what I was looking for.
Have you seen?
Oh, yes, acknowledge you said it, but I was looking for the explanation. All right, so let's look at
I said it.
Oh yeah, and I didn't get you. I didn't get your explanation. You never convinced me.
I said that the image will be virtual. The image form will be virtual. That's comes to negative.
Ah,
Yes.
okay, then 2 out of 3. Let's look at the other convention. Right after this, we'll look at how to use the convention one by one with a question. Especially the one I gave you to try. Yaba, are you there? Yaba? Hey,
Yes,
as-
please.
and you are quiet. You are observing. So let's look at the other convention. The other convention is the NC convention. NC means New Cartesian convention. New Cartesian. This one follows the Cartesian plane, X, Y axis. If this is a concave mirror, let me off the lights more and see. I think this is better, right?
Yes, please.
For NC, if the image is real, if image is real, then object is here, image is also here, whether magnified or diminished. Under this convention, this is the pole. Measurement is always taken from the pole. Under this convention, all measurements taken in front of the mirror please, the NC convention follows your Cartesian plane, your X, Y axis. Okay, under the Cartesian plane, whatever is here from the 0.2 is negative X. Whatever is here, positive X. The same thing applies up there. Okay, so in determining that whether virtual minus and the NC convention is what is used to affect the object height and image height. So everything, every measurement in front of the mirror is considered negative. Every measurement behind the mirror is considered positive. So for concave mirror, let's try U, F, U, R, F, and V. Let's judge. For concave mirror, what do you think will be the sign to be attached to U? Yes. If you are ready, just answer and then let's move on. What do you think will be the sign to be attached to U? For concave, as far as
Say,
NC convention is concerned.
say, will you be negative?
Hey, is there a question or answer?
Say, it's partially a question and an answer.
I want you to pick one.
U is negative.
It's negative. Why?
Say because
Mhm.
it's in front of the mirror is negative.
So all measurements are taken from the pole. So If you want to measure the object distance U, you start the measurement from P to where the object is located. And so that's negative. V, sorry, radius of curvature. Will it be positive or negative? Yes. Inshira,
So please it to be negative.
why? As for my why, very, very quick at it. Why?
No, that because all measurements taken from the mirror is negative.
Yeah, yes. So it is because, no, for the center of curvature for concave mirror is real. When the mirror ray hits the mirror at 90, it will pass through that point. So it's a real thing. And so the radius of curvature is real. And so when you are measuring it, you measure from the pole to it. So minus F. Yaba, F. Will it be positive or negative? Yaba. Will F be positive or negative? Yaba, are you there? Maybe Yaba is not there. Ekweadoma. Ekweadoma, what do you think? Hey, your line is fading. Charlotte. Hey. Ekweadoma, your line is fading. Anybody? Chrysler, Vina, and Co. What do you think? Evresi, Nanakwia, what do you think? Ama, Adwas, and tell you there. Okay, Akwia is saying it's negative. Who can explain why? Yes, it is true, negative, but who can explain why F will be negative? If you are ready with an answer, please go ahead. Nanakwia, go ahead.
Miss Lydia,
Mhm.
Lydia, please. I think it's negative because the focal point is real.
It's
And
real.
then you said measurements are taken from the poles, like when you take the measurements, they are the negative side.
Exactly. So minus. Now, lastly, for image distance V, will it be negative or positive? Will it be negative or positive? The image distance V. Oh, let's be quick and then see how we can apply. Will V be positive or negative?
Positive.
Nanekwa, go ahead. Hey. Okay, so V would be either positive or negative, depending on the nature of the image formed. If the image form is virtual, okay, it will be in front. The image will be in front of the mirror if it's virtual. So measurement from the pole to the image will certainly be in front. If the image form is virtual, then image distance V will be taken from P to X, and so it will be positive. So this can be positive or negative. depending on the nature of the image formed. Let's quickly look at it for convex. For convex mirror, objects in front. So clearly you would be, what would be the sign to you? Will it be positive or negative? Quick one, quick one. Amma, let's respond quickly. For convex, we are still using NC.
Okay, yeah.
You, what will it be? Oh, I'm not happy with the time wastage. What do you think? Just give me your opinion. The rest, you go ahead.
I think you will be positive.
P is being measured from, this is a pole. Okay. And if you draw the vertical axis, this is anything in front, this is anything behind. So what will be you? Erase it, come again.
Yeah.
So U is negative.
Okay, I see.
Then F. What do you think will be F? If you want to answer, don't waste time. And don't call me before, just go ahead. What do you think will be F? Will it be positive or negative? F will be positive because this has a virtual principal focus and it is always behind the mirror. What about R?
They're positive.
R will also be positive because it is also virtual behind the mirror. Then V. Then V. Will it be positive or negative?
Positive.
V would be positive because it forms a virtual image all the time. And the virtual image is always behind the mirror. Okay. So these are what goes into RP and then NC convention. Let's look
Sir.
at you.
So V can also form negative.
Pardon?
The V cannot also form negative.
You see, you mean V can also be negative?
I'm asking, can V also be negative here?
For convex mirror, it always forms a virtual image. But in this context, virtual images are always behind the mirror. So whenever you are measuring the image distance, it will be from P to the image. Virtual images would always be behind the mirror. So for as far as convex mirror is concerned, the image distance would always be here. So it will always be positive.
Okay, thank you very much.
Okay. So let's look at the question I gave you and use the conventions to solve. So a mirror, a concave mirror has a radius of curvature 24 centimeters. So here they've specified that it's a concave mirror. They've clearly explained that we have a concave mirror. In some other questions, the nature of mirror, you must deduce the nature of the mirror. And we'll look at questions which will require that. So a concave mirror has a radius of curvature 24 centimeters. So R, we are told, is 24 centimeter. This is concave. The mirror is concave. How far is an object from the mirror if an image is formed that is? So how far is an object from the mirror? So we are looking for the object distance. If an image is formed that is A, virtual, and 3.0 times the size of the object. So here, you see, we are only giving the magnitude of the absolute value of the linear magnification, and we are told it is 3.0. There's no unit because V over U, they are all distances. HI on H naught, they are all distances, so they cancel out. So here we are giving the magnitude and no signs to them. Is that okay? We are told that
Yes, please.
if the image form is virtual and 3 times the size of the objects, so the information given to us is that image formed as virtual. Very, very important. So if image form is virtual, then using RP, real is positive convention, it means that V must be negative. V must be negative. So using 1 on F is equal to 1 on U plus 1 on V. Straight away, let's find magnification M is equal to V on U, and this is equal to 3. So it means that V is equal to 3U. And because the image is virtual, this must be minus, V must be minus 3 on U. Why? Because image, we are told, is virtual. So if image is virtual, once I have the radius of curvature, F will be equal to 24 over 2. Because R is equal to 2F. R is equal to 2F, so F will be 24 over this. And this will be 12 centimeter. This is also positive because it's about concave mirror. Please, are you okay up to this level? Are we okay up to this level? All right.
No, please.
So let's put in our values. 1 on 12. The object distance, we have indicated it to be U, but that's what we are looking for. So 1 on U minus 1 on 3U. So it changed from positive to minus because of V. So what is left is mathematics, LCM. 3U. U goes into this 1, remainder 3 minus 1. So we have 1 on 12. So 3u is equal to 2, 2 by 12. Therefore, u is equal to 2 by 12 all divided by 3. This and this 4. This is equal to 8 centimeter. So object distance will be equal to 8 centimeter. So it means that we must place the object 8 centimeter from the mirror to form an image which will be 3 times magnified as an object. Please, are we okay?
Yes, please.
Please go ahead.
Okay. I want, and I'm coming. I want to relate something. Look at what they are saying. Let me connect this to the ray, using the ray diagram. The focal length is 12. So if I measure, assuming this is F, and F is 12 centimeter, it means R is this. R must be here, the same distance, to give me 24. Object distance, 8. Object distance, 8. Meaning the object, look at it, the object is between the P and F because we had U to be equal to 8 centimeter. So if I measure 8 centimeter from the pole, this is where I must place the objects. Now, whenever you place, connecting this to the ray diagram, whenever you place an object between the pole and the principal focus, what is the nature of the image formed? Yaba, you there? Hey, Enshra, whenever you place an object between the pole and the principal focus, what is the nature of the image formed?
The image is formed behind the mirror.
So the image is virtual,
And then it's erect.
erect. Will it be magnified?
Yes.
So it means that whatever we got actually makes sense because we are told that the image is 3 times magnified. Okay, and the image is virtual. So when you place the object 8 centimeter within it, it must give you such image. Class, are we fine?
Yes, please.
I'm going over for the last time. Okay. Now we have other questions B to also look at. So let's continue. I think it will help and bring something okay from it. So the B question says, if the image is real and 3 times the size of the objects, so how far is an object still object distance? If this time the image is real and 3 times the size of the object. Even before we go through the calculation. For a concave mirror, for the image to be real and magnified, for concave mirror, for the image to be real and magnified, where must the object be placed? using our ray diagrams. Where must the object be placed for the image to be real and magnified? Look at it and then tell me. Just look at the ray diagrams, whatever we went through, and then tell me. Yes, have you seen something? For the image to be real and magnified, where must the objects be placed? Hey, check, okay, on your ray diagram, the image formation we had and the spherical mirrors. Yes. Okay, so it must be placed between C and F. Okay, object must be placed between C and F. If C and F, then it means that for this particular position, object distance must be greater than the focal length F, because the object is between C and F. So the object distance must be greater than the focal length so that we have such an image. Class, are you okay? Are you okay?
Yes, please.
And we've had our focal length to be 12 centimeters. So it means the object distance must be something greater than 12 centimeters. So let's use our calculation to see if we have this. So this time we are told image is real. Image is real. Magnification is still 3 times. Absolute value is still 3 times. So we have 3 V on U, meaning image distance V would be 3 times U. Okay. If 3 times U, and this time around, image is real. So we are still using the RP convention. So this is plus. Image distance V is plus because we are using the RP convention. So 1 on F is equal to 1 on U plus 1 on V. This is 1 on 12 equals 1 on U plus 1 on 3U. If we take the LCM, we have 3U, this into it 1, remainder 3, plus 1. So we have 1 on 12, this is 4 on 3U. So 3U equals 12 by 4. When we divide through by 3, we have this giving us 4. So U equals 16 centimeter. And 16 centimeter is just greater than 12. So we are there. Hooray. Anapia,
Let's stay there.
are you okay?
Yes, please.
Hooray. You just confirmed it. Then the last question is that if image is real and 1/3 the size of the object, if image is real and this time image is diminished. Now, for the image to be diminished, I don't know, to Today, I don't know why I'm why. For the image to be diminished or reduced in size and still be real, where must the object be placed? Using our ray diagram for a diminished image, a diminished real image, where must the object be placed? Yes. I'm with
Between
you.
C and infinity.
Between C and infinity, meaning behind C. So it means that our final answer U must be anything greater than the radius of curvature. And radius of curvature is 24. So for the image to be diminished and real, we must have an object distance which is greater than this. Because using the ray diagram, the object must be placed just behind C, or between infinity and then the center of curvature C. Class, are you following?
Yes, please.
Okay, so let's go to the bookmakers. Hey, Charlotte Adoma. Charlotte.
Yes, please.
You've been so quiet today. What's the problem? Are you sick?
No.
Hey, you don't even cough. Hmm. All right, so 1 on 12 is equal to 1 on U, but we were given the magnification M to be equal to 1 on 3. So if the image is real and 1/3 the size of the object, so it means that V, because M is 1 on 3, V on U, V will simply be equal to 1/3 of U. So this is plus 1 on U, 1/3 U is U on 3. And U on 3, the inverse of U on 3 is simply 3 on U. If you use 1 on 1 times 3 on U. So the inverse of U on 3 is just 3 on U. LCM U 4, 1 on 12. Therefore, when you cross multiply, U is equal to 12 by 4. And this is equal to 48 centimeters. I earlier said that for this to happen, U must just be greater than the radius of curvature, or the radius of curvature, and we've just had that. Please, class, are we okay?
Yes, please.
Hey, today you don't talk to me, oh. Are you okay? And you won't mind me, only Amma will talk. Meanwhile, I have address and Adwadema, Sawa, Equia Amma, Chrysla, Efe, a lot of you around. 16 strong voices. Let's use NC to see what we have to see. The NC convention. Do I clean the board? Class, do I clean the board?
Yes, please.
Yes, please.
NC. Anything in front of the mirror is negative. Anything behind the mirror is positive. Still, it's a concave mirror. The mirror hasn't changed. Its radius of curvature is 24. Magnification is still, yes. So since this is concave mirror, R will be negative. And so F would also be negative 12 centimeter. A concave mirror, okay, so this has real and it's in front of the real principal focus and it is in front of the mirror. The reason for which F is a negative 2. Object is always placed in front of the mirror. So U is negative. We are told that the image formed must be virtual. Virtual images are formed behind the mirror. And so here V must be positive 3U. I'm just connecting it to what we've done. In A, we are told image is virtual and 3 times magnified, 3 times the size of the object. So if the object size is U, then V will be plus 3U. And this is because V image is virtual. Virtual images behind the mirror. So that will be positive. Please, are we fine? Are we okay?
Yes, please.
So using 1 on F equal 1 on U plus 1 on V. This is minus 1 on 12. This is minus 1 on U. This is plus 1 on 3U. Okay, so we basically have 1 on 3U minus 1 on U. LCM 3U. LCM 3U. LCM 3U. This is 1. This is minus 3, giving us minus 1 on 12. So we have minus 1 on 12 is equal to minus 2 on 3U. So that when we make 3U the subject, we have 3U is equal to 12 by 2. So minus, but it's obvious the negative will cancel out. So we have U giving us 12 by 2 all on 3. This and this 4. We have 8 centimeter. Same value as we had before. Don't forget, we inputted the negative to denote that it would be in front. So the object distance must be 8 centimeter, just as we had in the first situation. Please, are we okay?
Yes, please.
Are you girls tired of
Please
calculation?
go over again.
Yeah, okay, let me take it again. So, you are tired of calculations, right? So, we are using NC convention. What's the mirror? Concave. NC convention, radius of curvature must be negative because it is in front of the mirror. F is also minus 12 because it's a real thing in front of the mirror. Objects. Object is real in front of the mirror, and so object must be minus or negative. What about the image? The question made us understand that the image A, virtual and 3 times the size of the object. Magnification the same, but we are told the image is virtual. Under NC, virtual images are positive because they are formed behind the mirror. Okay, so NC, please, X and Y axis. So the image will be here, and so V will be positive. So this is plus 3U, and I'm using the magnification. If this is 3, then V will be equal to 3U. That's what I'm using. And because the image is virtual, formed at the other side of the objects, that is why it is plus. Get the difference between the RP and then the NC. So when you put this in, you have 1 on F equal to 1 on U plus 1 on V. Put in your values. Okay, minus 1 on 12 is equal to minus 1 on U, taking care of my negatives, plus V is positive, so 1 on 3U. Are we okay up to this level? When you rearrange the terms, you have 1 on 3U minus 1 on U. I'm bringing the positive before the negative. So if we take the LCM, we have 3U. This is 1 minus 3 is equal to minus 1 on 12. So that we are minus 2 over 3U minus 1 on 12. The negative would handle each other. So that when we cross multiply, we have 3U equating to 12 by 2. When you divide through by 3, this goes into this 4. So you have U equal to 8 centimeter. Just as we had when we used the RP. Are we there?
Yes, please.
Okay, so let's look at B. When it is real and 3 times, you have to confirm your understanding of the NC convention. When it is real and 3 times the size of the. So this time we are told image is real. M is still 3 times. So if image is real, once it's concave, R will still be minus 24. F will still be minus 12. Okay, U will still be negative. Then V will still will be minus 3U this time around. Because this time, the only difference is that the image is real. If it is real, then it will be formed in front of the mirror. So 1 on F equal 1 on U plus 1 on V minus 12 minus 1 on 12 is equal to 1 on U negative 1 on U minus 1 on 3U. So minus 1 on 12 is equal to negative out 1 on U plus 1 on 3U. The negative will cancel each other. So we have 3U, 3 plus 1. So 3U is equal to 12 by 4. When we divide through by 3, we have object distance equal to 16 centimeters. Is that what we got for RP? Class, is that what we got? All right. Try the last one. I want to see how you can use NC, okay, to get the last one where we had object distance to be 48. I'm giving you 3 minutes to do that. 3 minutes, start work. Please don't be. Hello.
What are we doing? What are we doing?
I want you to try the last one using NC. See, when the image is real and 1/3 the size of the objects, use NC to look for U. When the image is real and 1/3 the size of the object. The same question I sent to you. I'm resending the question again. So I've just dropped that on the platform. So you have to answer the C when the when real image is real and 1/3 the size of the object. But I want you to use NC. As I have demonstrated to you. Nanek, are you okay?
Yes.
You've got into. Okay, because of time's sake, let's pick it from where you've got into. So, an object 30 centimeters from a spherical mirror. So straight away, object distance is 30 centimeters. 30 centimeters from a spherical mirror along the central axis. The absolute value of the lateral magnification is half. So this is equal to half. The image produced is inverted. What is the focal length of the mirror? So F. But I'll want to know the kind of mirror. Class, what kind of mirror is being talked about here? What kind of mirror is being talked about here? Any feedback? Oh, share with me. Bushra Ajua, you are here. Sawa Ajua, what kind of mirror is being talked about here? Ajua Sante.
Concave mirror.
Why? Why concave, but not convex?
Means this. They said the image is inverted, and in convex mirror, the image is always upright.
Thank you. Fantastic. Okay, these are the reasons. So it means that when a question is given, you just must pay attention to the details, because that is exactly what will help you out. Once the image is inverted, it means it's a real image. Once image is inverted, it's a real image. But convex mirror always forms virtual images. Yes, image is diminished because it's been reduced by half, but it is inverted, meaning this image, this mirror must be convex, concave. So if m is equal to half, then half, which is equal to v on u. So v would be equal to u on 2. Okay, so using real is positive convention, image is real, positive, because all real images please, I'm coming, eh? Let me pick this call from school and get back to you. Hello. So using RP, V is positive because image is real. Okay, once this is concave, F is positive. Object is always real. So 1 on F is equal to 1 on 30 plus, this is equal to 30 on 2. So we have 15, 1 on 15. 30, 1 plus, this is 2. We have 1 on F, giving us 3 on 30. Therefore, F is equal to 10 centimeter. Please, how many of you got 10 centimeter for the focal length? Okay, the next year I got it. Ishra, okay. Priscilla, oh, that's great. You are really making me proud. Okay, yeah, let's quickly use the other convention, RP. Sorry, NC. NC. The same for NC, U would be negative. F would be negative. Then V would also be negative. So minus 1 on F is equal to minus 1 on 30 minus 1 on 15. So minus out 30 This is 1 plus 2 minus 1 on F minus minus. So 1 on F is equal to 3 on 30. F is equal to the same value, 10 centimeter. How many of you got the same thing using NC convention? Lizzie got it. The rest you couldn't finish. Okay, so that's it. Okay. So class, if you have any question, ask. If you don't have any question, I think we'll call it a day, but I'll send about 2 examples to you. I'll forward. Hello. I'm in Patrolman checking.